I suppose the question will come up, how do you read this dial? You know, it's really not very hard, but let's take a look at it. First of all, it's 1 megacycle ride. So each one of these divisions down here is 100 kcs, or so go down here and you look at your band switch and you say, well, which segment of the band am I on? Usually 50 to 50 50 to 51 is where most of us are operating on sideband. And say, let's say we want to find 50.125. Well, here's 50.1. You can see those right there. It says 50.1. And so we want to find 25. Well, here's 20 here. So you just go along until, find out where, let's do something simple. Let's do 5150. Here, this heavy line here is 50 kcs. So where the dial intersects this diagonal line, you're going to run across and read your frequencies. So you know you're on 50.1. Here it is intersecting this line. We'll follow that over, and that's 50. So that's 5150. We want 5125. We're going to find the 25 kc line. Here's 20 and here's 30. Well, let's follow 20 over. And here, second one up between 20 and 30. So it's going to be where those two intersect. And that's going to be 51, 10, 20, in the middle, 25. Now, we've got a logging scale on here. And this logging scale is approximately 2 kcs per division. So we'll put it on 51 and we'll find the logging scale is on 0. So let's go to 12 and a half. That's half of 25, or 2 kcs per division. Should be about it. Look at the pointer here. Run up 50, 10, 20, in the middle, 25, 51, 25. So even though this is a logging scale, that frequency is always going to come up in the same place in the scale. So it happens that it's about 2 kcs per division, but you can remember 12 and a half, which happens to be 125. So anyway, that is how it works. It's a little bit old-fashioned. It's a lot old-fashioned. AM might have been the predominant mode. In fact, it was the predominant mode in 1962, 64. But the sharper operators certainly wanted to work single sideband because of the, the 10-to-1 advantage of working sideband versus AM. And so this receiver absolutely was designed as a sideband receiver. Unfortunately, this dial is not certainly not what one would want today, and even then was what we'd consider less than wonderful. It certainly is a shame that this receiver doesn't have a linear master oscillator like a Collins or a SB or Hot Water Series Heathkit, or the latter day FT Series Yaesus or Kenwoods. But anyway, actually those have coil and capacitor VFOs, but they have much better dials. And this radio certainly could have benefited from a dial with a 1 or 2 kc readout, and it certainly is linear enough and accurate enough that it could have had one. But oh well, this is what it is, and I think stability-wise they did just as well as just about as well as you'd have done with an LMO, but they didn't get the linearity that an LMO would have given, and this receiver could have had a 1 kc readout on the dial without any trouble with an LMO, and that would have made it seem as modern as it really is otherwise. Well, our receiver's been off for about 4 or 5 minutes now, and we'll just go ahead and turn it on. And there's the inrush current now. So I think it had been sitting on the shelf so long, I probably should have started it up stepwise and let those electrolytic capacitors charge up slowly. I think it didn't like what I did to it. Okay, what we're going to do now is start up the Interceptor B receiver. This does not have a recapped power supply. I've been using it with the original caps for years. It started to hum, and I took it off the operating position to do some service on it. But let's just go ahead and start it up here. So there's about the same inrush current as the other one. It's down to 50 watts, sitting there in the standby mode, and like the other one, it's coming up a little bit as it warms up to about 60, 70 watts. Gonna let it just warm up a little bit, and got the same antenna on it. It's only a couple of minutes later, and we'll see what it does. Okay, putting it in the receive mode. There we go. Turn around and see if we can find that station. I preset it the same way I did the other one. Something's not right here. Well, my dial calibration was off quite a bit. This is reading 80, 5080, and that's about 10 kcs high, but you can see the signal strength much higher. So there's the operation of the vernier. Which you can see is a very handy feature to have. That's the broad position. That's with the crystal filter out. So that's how sharp that crystal filter is. That's about 1,000 cycle tone. That's just going right away. That's vernier's supposed to have a range of about 1 kc. sharp that is. With this crystal filter out, you can still hear it. With the crystal filter in, you cannot. So there's a marked difference in selectivity there, which is what you want. There's the adjustable noise blanker. Oh, it doesn't seem to be humming too bad now. We can go up to the sideband portion up here, but I don't think there's anybody home. Nobody home. So no sideband activity at this point. So there's a difference, but this receiver has been peaked up and aligned and all that good stuff, and the earlier version has not. So, and let's look at the power consumption here. Need to listen to that. Drawing about 70 watts. So, I think that this is one of the absolutely the nicest tube-type VHF receiver anybody ever made. But it's as a tabletop sideband receiver with this all-bander converter on it. It's really a wonderful wide-range sideband and CW receiver. It's a great pleasure to own it and to use it. W6WUH. As long as I've got these Clegg set up here, I'm going to just show you how the all-bander converter works into the Interceptor B. The controls are very simple. It basically is a general coverage converter that upconverts from HF to 6 meters. So you select the band segment you want to use, basically 80 meters, 40 meters, 20 meters, WWV, 15 meters, 10 meters, and any general coverage thing in between. Select the band that you want. It's got a pre-selector just like any good receiver does. You just peak the signal and you do the tuning down here, and it's in 1 megacycle bands. So if you've got this segment here that's 3 to 4, 4 to 5, 5 to 6, and 6 to 7, there's 4 1 megacycle bands. Take your pick. This one is going to be 7 to 8, 8 to 9, 9 to 10, 10 to 11. So we're going to go up to the 40 meter band, and we'll use 50 to 51. And then whatever, you just take this to be 7.0 and work your way up the dial just like you would any other receiver. So we're going to go to, let's see what time it is. Oh, well, we'll look up around 7,200, 7,300. There'll be some signals in there, and we'll see what we can find. So first thing you do, I've got this thing hooked up in the back. Just go over here and select converter, and watch what happens. It turns itself on because it's getting its V plus and its filament voltage from this receiver, from the accessory jack in the back. And then this is selecting the receiver input here, 2 meters, 6 meters, in this case is converter, or if we had some other optional tuner outboard, we could use that, but we're going to use this. So we'll select 40 meters and turn it on, give a listen. LED lights on.
No, not really, I'm not. Okay, there's some distortion there, and I just don't know what it could be other than you're hitting it with too much gain. It might be a little RF in there that might be doing it. You're running a battery supply or power supply over. Would you mind if I change my microphone? Let me know if you have a distortion. Yep.
So, typical ham thing going on here. See what else we can find. I had my battery charger on. That's what all that awful noise was. So I'm hearing a little audio distortion in there, which I didn't used to hear, and that's why this receiver came down to the bench. But anyway, there's a couple of signals on 40-meter lower sideband using the all-bander and the Interceptor B.
You'll want to shield the inductor very well, so it'll be isolated from any external things. Just keep moving. Now, how the dickens would I shield that? Now, and the other thing. Let me see if I have it. The experiments that I were doing